The following video shows a recording of the presentation How to Read Thoughts with Eye Tracking in Virtual Reality, which I've given during the Prethix workshop at the ETRA conference in Tokyo this year. We will also show first results of an ongoing research project in collaboration with our excellent partners here in Germany and funded by the Federal Ministry for Research, Technology and Space. If you have any questions about this presentation, please leave them in the comments or write us a direct message over our contact form.
A wonderful good midday to Japan. At the moment when I'm recording this video for you, it's 6 p.m. in the afternoon in Germany, so the sun is still shining. When you will watch this presentation, I will sleep, so that's real globalization. Welcome to the second presentation this morning. You know now Murat, Teresa, Celine and Alyosha. My name is Michael Raschke. I'm co-founder and managing director of Blickshift. We are an eye tracking analytics company from Germany. We are on the market now for almost 10 years and our flagship products are Blickshift Analytics, so an eye tracking analysis software, and Blickshift Recorder for recording data in eye tracking experiments. We are interested in the topic ethical and legal and social implications in eye tracking since 2018. Working on that together with scientists in the community because we believe in that eye tracking technology can only be successful if it will be accepted by the society. And since we will learn, or you already know, and we will learn during today's workshop, eye tracking data can be very sensitive. There are many different questions which have to be answered so that products in the future will be accepted by society, which of course is the fundament for a successful business model and so for the development of a company. So let's dive into this question: how to read thoughts with eye tracking in virtual reality. Let's look into the future. What can happen next? Eye tracking technology is moving from the laboratory to the real world. I think this is something we can see in different application fields of eye tracking. It can be virtual reality, augmented reality, it can be gaming, it can be medical tech. An exciting time for companies and researchers to work in this field. But for the questions we want to answer or discuss in this workshop, what does that mean? From the technical perspective of an eye tracking analytics company, this means that in the future we will have something which we might call big eye tracking data. So what does big eye tracking data mean? First of all, what is the reason why we can talk about something like that, about big eye tracking data? It's the evolving of the eye tracking technologies. Eye trackers have progressed from costly, high-end professional devices to affordable consumer-grade solutions, paving the way for future integration into smartphones and personal smart glasses and enabling large-scale everyday eye tracking applications. When we look at the numbers, we can see the following development. At the millennium, a good high-end eye tracker cost around 40,000 euros, which is equivalent in US dollars. And during the last 2 decades, these prices have been fallen. And especially when it comes to affordable webcam devices or even integrated in smartphones with these little small cameras, eye tracking is now possible and will be, and this is my prediction, will be possible with a high level of data quality in the future. And parallel, besides the desktop systems, we have also this development of head-mounted systems. And in many AR devices and VR devices today, you already find eye trackers. And these system costs around, I don't know, if it's expensive, 1,000 euros. If you think about the cheaper ones, a few hundred euros or dollars. The stimuli and the context also have been changed. Eye tracking is moving from static 2D images to dynamic 2D, 3D content and real-world unconstrained environments. In addition to that, the user base is expanding. When we usually talk about participants in a user study, as when I started to do my PhD in this field, 30 participants were a lot. Today, we can talk about hundreds if we do webcam eye tracking, or potentially millions if we think about glasses, AR or VR devices. And the data complexity is growing. So this means that the diversity and the volume of data demand advanced real-time analysis and big data visual analytics methods to unlock the potential of future eye movement applications. It's an exciting time, also with a lot of questions regarding the ethical, legal, social implications. I did my PhD in visualization research, and when I work or when I enter some kind of a new field, and I want to learn and want to study this field, and I want to find my path through this field, I usually use visualizations. So let's try to break what I've said so far down into a simple visualization. So let's say we have big eye tracking data. More and more what we see is that both scientists but also applications, commercial applications, go beyond statistics. And the magic word here is machine learning. So we have big eye tracking data in combination with machine learning. I did my PhD at the interface of cognition science and visualization research. That's why I bring in here the term cognition simulation. So far, I do not see that in the scientific community as far as what I'm reading in the literature, but it's a path into the future. So what can happen if we combine machine learning and cognition simulation? If we do so, this will lead to an extensive knowledge of human mental and emotional dynamics. And at this point, it's absolutely important to talk about ethical, social, and legal implications. And this is this beautiful combination of data, technology, and the ethical, social, and legal science, a real interdisciplinary approach, which we are working on here and discussing with you in this workshop. So, in contrast to scientists, our perspective on all of that is from a commercial point of view. We are a company. I was wondering how I can bring in this business perspective. And since we are living in a world of artificial intelligence, my idea was, let's ask ChatGPT and let us explain how business can be done when we are all wearing augmented reality glasses with integrated eye tracking. And this is what ChatGPT tells us. So, if everyone in the near future wears augmented reality glasses with integrated eye tracking, companies will have access to a continuous stream of highly granular real-time behavioral data. This opens a wide range of business opportunities, which sounds wonderful for a company or for an industry. Here are several ways companies can monetize this eye tracking AI data. And then you can do that by yourself. Also, this was a fresh new channel in ChatGPT. We'll find something like hyper-personalized advertisement. Then retail e-commerce optimization. Market research, consumer insights, UX and product design services, gaming and entertainment, healthcare, mental health, education, training, security, fraud detection, Real estate architecture, really interesting. License case data aggregates. And when you look into the details, it sounds very interesting for doing business, but there are many open questions which have to be discussed before bringing these products on the market in a way that society really benefits from that. That's my or our perspective on that. And what I find interesting is that ChatGPT finally ends this summary or this presentation with some considerations, as I haven't asked ChatGPT for that. It comes by itself with that, and says here privacy and consent are critical, and ethical data usage. So welcome to this topic, ChatGPT. It makes absolutely sense to talk about that. So let's make it concrete. Here's a glimpse into the future. In our research project, together with the team here of the workshop with the other scientists, we're developing a game demo at the Games Convention 2025 in Cologne in Germany. The Games Convention, so the Gamescon, is one of the biggest games conventions in Europe, where new games are presented, where the whole community is coming together. And in August, we will present their interactive eye tracking game demo. And the idea is that visitors experience a two-room VR memory challenge, where eye tracking is used to assist gameplay in the second phase. The selling point to the gamers is that players take part in a real-time study exploring the intersection of gaming and emerging eye tracking technology, so they can learn something new and can help us to understand this interaction between VR, eye tracking, machine learning, and society. They will do some ethical and social surveys by the colleagues here of the workshop. So we will ask them how they feel about eye movements being used potentially, infer their thoughts, emotions, and intentions. And around that, we want to further strengthen our public dialogue on tech and privacy topics with eye tracking. So I give you a brief introduction into the game, and then we will have a brief look on the real game demo. It's a two-room challenge scenario. So the player starts in the first room and is given 1 minute to look around and memorize the positions of objects on a table. Then, after time is up, the objects begin to fly around and scatter chaotically throughout the room. The object is return all objects to their original positions on the table. And then, this is where we're still working on, a gate to the second room opens. And then in the second room, the gamer is doing the same task, but with eye tracking based support. So something like a magic eye helping to locate objects. This is the basic setup. And here we can collect a lot of eye tracking data, can find something about the gamers, and we will confront the gamers with this information after the game, and then they discuss that with us and they fill out the survey, and we'll get this information for further research on this topic. So let's have a look into the game. Here you can see this hall. It has some kind of a mid-age atmosphere. We have these 3 tables, and we have different objects on these tables. So the gamer is now walking around, is looking around. Later we will show, or we will have a look at the eye movements as well. We do not see them at the moment, but the gamer is looking around. And then after a while, these objects are suddenly flying around, and the goal is now to, as quick as possible, collect these objects. So go to one of these objects, grab the object, and bring the object back to the right position, hopefully memorized before when looking around. And this is done by these different objects here. This is done with these different objects, like with this book here as well. Just jump forward here, so move to the table on the right side, and then this object as well to the table, on the table in the middle. And this concrete task will help us to study the eye movements and to analyze the mental processes, as said, to confront the gamer afterwards with some information. To show you a quick demo how this can be done already today with some simple visualizations, I will show you in a minute a parallel scan path visualization of the eye movements. And so that you understand what happens here and how I analyze the data, let's have a look how this visualization is working. We have the different areas of interest on a stimulus, and then we visualize the gaze durations on these single objects as vertical lines on these different columns here. So the time is indicated from bottom to top. So we started the eye movements at AOI 2, then we have a transition to AOI 1, and then back to AOI 2. For whatever mental reasons this participant is performing this eye movement here. Then the participant continues with eye movements to AOI 3. And this path here, or this visual, this line of transitions will help us to understand mental processes of this gamer. So let's analyze now the eye tracking data, or some eye tracking data from the game. On the screen, we can see Blickshift Analytics. We see three main parts of this visualization and analysis tool. On the left side, we can see the real situation, so where the participant has focused on. Here in the center, we can see with colored coded all areas of interest which have been focused on. And here on the right side, we can see now this parallel scan path visualization, which I've shown you before. What we can see is that the participant here slightly moved the attention to a mushroom visualization or mushroom object on the table, as it's highly granular, the visualization. Technically how it works is we take the gaze vector of the eyes and we intersect this gaze vector with the objects in the Unity 3D scene, and we write down, or we write this information, which object has been hit together with the identifier of the object to the hard disk, together with, like, for example, the X and Y coordinate of the eyes. We pre-compute fixations as well. You can also store some interaction information, some location information in the scene, and everything can then be visualized, for example, in Blickshift Analytics, to find these patterns and to understand the mental processes. What is interesting is because we ask, the participants or the gamers know the task. So what they do at first is, of course, try to memorize the objects on the table. And this is something which we can nicely see here. So here, for example, is one object the participant has focused on to memorize. We have here another object, this book here, for example. And this is the memorization phase. And by studying this, for example, I can learn how this gamer, especially this person, is memorizing objects, how long it will take, if this person is doing some cross-checking, if he or she is coming back with the eyes to just focus something more in detail. I can also learn, for example, if the gamer already knows this object or is familiar with this class of objects. If this person is doing only a few fixations, then the objects, as I said, are flying around. And if the participant quickly can identify the position again, for example, this can show me that these objects might be interesting for this participant or for this gamer. In addition, I can understand more about the 3D mental processing or the mental processing of 3D information, so locations, distances, and something, just by analyzing the eye movements. And all of that shows me, for example, something or tells me something about cognitive load, arouseness, excitement, and something like that. And this is only the semantic scan path. So we do not talk about the deeper level of changing of fixation frequency, microsaccades, pupil dilation, saccade length, saccade frequency, all that stuff. We have also both eyes available, so we can learn something about 3D space recognition, and then with some brain models also about something about the neurological processes behind that. That's really here only the semantic level where we can see which objects have been focused when, for how often, and what happens then later once these objects are flying around. So here we are now at roughly 60 seconds. So the objects have been flied around. And now the goal is to grab this object. So the attention is completely what we can see here on the right side on the red glass here. So the attention is there. That's not unusual. As that's something like which you have also when you click the mouse somewhere, and usually with 90% or 95, I don't know the exact numbers, your eyes are at this position on the screen, as it makes absolutely sense, so that the attention is now here and the participant is now moving this object back to the table, for example. Here we can see that with the book as well. So the book is being grabbed and moved then here to the, let's see, no, it was moved to there, and then here to the right side, so to the right position on the table, and here then with the third object as well. With some practice, I as a human, not as a machine, can find patterns in this data and can correlate that with some cognition simulation or mental processes models, with memory models, something like that. And what I said at the beginning, if you do that with 30 participants, it's nice to find something and to publish that. But imagine you would do that with 100, with thousands, with 100,000 of participants. Of course, we won't do that with visualizations again, perhaps in the first step when we train the algorithms. But later, when everything will be done automatically, this pattern recognition will be done by machine learning for millions of users out there to analyze the real inner mental states, the cognitive processes of the gamers here in a VR example. So that's the technology, and like with this software, it's available, so it will be exciting to see where this will go to. So in contrast to scientists or researchers, for a company it's interesting to make money, to run a business, to come forward, to develop new things and to bring them on the market. I don't know if you recognized the last sentence of ChatGPT, and that's really interesting. It asked me, would you like a business case or a fictional startup idea based on one of these opportunities? Hey, why not? So let's continue and see what we will learn. So this is really what I entered, so that would be really great. And then it started, and here comes a fictional startup business case based on gaze-based hyper-personalized advertising. So startup idea, Glimser, the future of attention-based advertisement. And then it really describes me how this business model could look like. And I will just go to the last section, as it's really interesting how simple this business model could be. And then finally it writes something like here, vision to become the Google of visual attention in the AR era. This sounds really interesting. So, and now when the era of the next Google or visual attention starts, what can we learn for this workshop about this result and about the last 20 minutes? So let's visualize it again. I extended my slide with a first box. Where does the data come from? And my opinion on that is it's only a question of time when attractive applications come around using eye tracking, either in VR, AR, in the real world, wherever, but there will be attractive applications and really small, affordable devices with a high data quality. And then we will have big eye tracking data. So we learned that we can combine that with machine learning, with cognition simulation. We learned something about the business model which can be built behind that. We will have, or the companies will have, extensive knowledge of human mental and emotional dynamics, because that's where they will build the business models on. And this will lead to ethical, social, and legal implications for sure. So, we are now at the end of this practical lightning talk. I want to conclude this presentation with some questions for the audience, which you can discuss right now or later. And I'm really looking for your opinion on that. So perhaps discussion point 1. How do you personally feel about technologies that can interpret thoughts or emotions from your eye movements? Would you feel comfortable using or recommending applications that rely on this kind of eye tracking analysis? Why or why not? Under what conditions, e.g. transparency, consent, would you consider such applications acceptable or even beneficial? What safeguards are necessary to ensure that eye tracking data is used responsibly, especially when integrated into entertainment, education, or consumer technologies? And then finally, how can interdisciplinary collaboration between psychology, informatics, and ethics shapes the development of eye tracking applications in a way that respects human dignity and autonomy? With that, I want to conclude my presentation.
Thank you very much for watching this presentation. If you like this video, please push the like button, subscribe to our channel and activate the bell so that you'll never miss a new video on this channel. And I'm looking forward to seeing you in the next video.